Hi, I'm Bill Karagounis, Group Program Manager of the Windows Performance team. System memory is a crucial resource that can dramatically affect the experience of any computing device. Regardless of the form factor, it's important that we keep improving how system memory is managed for you in the background so you can switch between applications really quickly. Today, I'm going to walk you through one of the operating system memory management advances in Windows 8. The ability to reclaim almost all of a MetroStyle app's private memory when the app is not in use, while still maintaining responsiveness when you switch back to the app. For the demo today, I'm using a machine running a 32-bit version of Windows, 2 GB of RAM, and a flash-based drive. Let's switch to the Task Manager to see the details of the running apps. As you can see, I'm running a number of MetroStyle apps. If you look at their memory use, you'll see that the memory hovers around 20 to 40 megabytes or so. There's a couple of notable exceptions. The Finance app is currently using approximately 80-ish megabytes. I'm now going to push the memory use on the system to the point where Windows senses some memory pressure. I'm going to do this by launching some additional apps through a script. Now, let's wait for these apps to get initialized, get up and running. Okay, now let's switch back to the Task Manager. Now when you look back at the Task Manager, you'll see something interesting has happened. The memory attributed to some of the suspended MetroStyle apps from before has been dramatically reduced. In fact, if you were to total up the picture before and the after picture for the apps that were running before I drove the machine harder, you'd see a few hundred megabytes of memory has been repurposed to other apps in the system. This is due to the fact that when MetroStyle apps are in the background, they typically get suspended and no longer touch their memory. This gives Windows 8 the option of repurposing almost all their private memory to other apps or system needs if necessary. This is different from desktop apps, as desktop apps need to have frequently accessed memory available, given they can run at any time. A key design point for this new functionality was to repurpose memory without impacting your experience when you switch back to an app. The memory pages are moved out of the app's process, queued up to be written to disk in the background, and are carefully trickled out to disk so that the associated I/O doesn't get in the way of any other activity you might be running at the time. We also want to write the app's memory to disk in a way that we can bring it back quickly and efficiently the instant you decide to switch back to the app. I'm going to show you what the experience of switching back to one of those apps that have had the memory repurposed feels like on this machine. But before I do that, I need to simulate a typical use pattern to ensure the pages of memory that will be repurposed have actually been written out. I could use the machine and make different memory demands for a few minutes, but for the purposes of the demo, I'm going to use a test utility to explicitly push out the memory contents to disk. So, let me fire up an admin command prompt, and let me get the memory into the state that you'd normally have it. Okay, so now let's switch back to an app that's had its memory repurposed to see what the experience of switching back feels like. For this part of the demo, I'm going to use the Finance app, which is currently showing less than 1 meg of RAM in use. I'm going to use the Task Manager facility to switch to it. Okay, you can see almost immediately that that app was responsive. This will vary on a machine-by-machine basis depending on the speed of the disk and the size of the app, but we're shooting for an experience that's very responsive across the broad ecosystem of machines running Windows 8. Let's now switch back to see what Task Manager is showing for the Finance app. As expected, the Finance app's private memory has been brought back in and is showing up in Task Manager. As you can see, this functionality allows for a larger number of concurrent apps in Windows 8 and also sustains a responsive experience when switching between apps. This is one of the advancements to Windows 8's memory management that developers don't need to worry about and you get implicitly when using Windows 8. The functionality I've described here is part of the consumer preview. Feel free to try it out. Thanks.